Hi, welcome to my YouTube channel on designing and building ML systems. My name is Manoranjan Pradhan. In this video, we'll discuss about important aspects of a machine learning problem formulation. The first step in defining a machine learning problem is to identify the problem type. This helps us streamlining our thought process, helps us identify the key algorithms to choose from, the key metrics to measure the performance of the models, and provides a methodology in the model development and selection process. Most of the problems the enterprises are solving today can be categorized into one of these categories as shown in the slide. It can be a classification problem, a regression, forecasting, recommender systems, or clustering. There are other kind of problems. The majority of them can be fit into one of these categories. After identifying the problem type, the next step is to identify the right metrics to measure the performance of the models. The performance of the models are typically measured during an offline evaluation using a holdout set like a test set. So the metrics that can be used, either one of these widely used matrices for different kind of problem types as shown in this slide, or a matrix which actually measures the business outcome of a model. In practice, you would have observed data scientists report all possible matrices when they build models. For example, I have seen people reporting different. For example, you would have seen when people build a classification model, they report all possible matrices like a precision, recall, F1 score, ROC, AUC, confusion matrix. But then how do I select a particular model based on which one of these matrices? One of the most important guidelines is that all machine learning projects should be single metric driven. And that particular matrix has to be identified at the time of problem formulation because it drives the complete life cycle of model development and selection process. So then how do we choose the right metrics? One recommended way is to understand the cost or the risk associated with the model failure. Now take the case of a credit risk modeling, where a bank wants to build a model to predict if a loan applicant will default or not default a loan. Based on the model's prediction, the bank will either approve the loan and disburse the amount or reject the loan application. Here the false negatives means the model has predicted the customer will not default, but the customer actually defaults the loan. So the cost associated with the false negatives are very high. If disburse the loan based on the model prediction, the bank can actually lose both the principal amount and the interest rate. Whereas the false positive means the model has predicted the customer will default the loan, hence the loan application is rejected, but the customer would have actually not defaulted and paid back the loan. There is also a cost associated with this, which is an opportunity cost for the bank. So one way to solve this problem is to minimize the false negatives as much as possible to avoid the highest risk. So the right metrics to choose here would be recall, because as the false negatives go down, the recall becomes very high. But minimizing the false negatives as much as possible indicates the bank becomes extremely risk averse, which in turn will increase the number of false positives significantly, which means the bank will lose a lot of good customers and hence will have a lot of opportunity cost. The best way to solve this problem is to minimize the total cost of the model. So you can associate a cost with the false positives and false negatives. For example, the C1 is the cost of false positives and the C2 is the cost of false negatives. And the total cost of the model will be C1 multiplied by the number of false positives, C2 multiplied by the number of false negatives. So here the objective is to find the right model and associated threshold or cutoff probability which minimizes the total cost of the model failures. Let's take another example of building a classification model to detect spam mails. So in this case, a false negative means the model has identified a mail as not a spam mail. Hence the mail appears in the inbox, but the mail is actually a spam mail. This is of course a cause of concern, but can be acceptable to a certain extent. What about false positives? False positive is a mail which has been identified as a spam mail, but is actually not a spam mail. And hence a good mail appears in the spam box. So as the number of false positives increase, there could be a loss of trust on the system. Hence, in cases like this, the false positives has to be minimized as much as possible, even at the cost of false negatives becoming very high. This is one of the reasons we see a lot of spam mails in our inbox. And cases where the false positives has to be minimized, precision can be a good metric to measure. Because as false positives go down, the precision becomes very high. So as we saw in both these cases, it becomes very important to understand both the failure types, the false positives and false negatives, to choose the right metrics to measure. So as a data scientist, you must involve your business and convey them that the model will fail in certain scenarios, but what are the cost and risk associated for these failure types? And then you can choose the right metrics to measure, which will drive the complete life cycle of model development and selection process. It may not be possible to measure the performance of the models in an offline evaluation mode all the time, especially in cases where the underlying business context changes very rapidly. The traditional metrics may not do the justice. So in cases where the business understanding is very deep, people use a business metrics to measure the impact of the model. For example, Netflix uses a metric called take rate, which is defined as the number of quality plays divided by the number of recommendations it makes and the user sees those recommendations. Here the quality plays is defined as the user playing a particular recommendation beyond a certain amount of time or probably has seen a certain number of episodes. Netflix uses take rate because it has realized the higher take rate means the higher total streaming hours or the lower in subscription cancellation rates. The other important requirement that need to be captured at the time of problem formulation are the deployment constraints. it's necessary to understand how these models would ultimately be deployed and the outcome of the models would be consumed. Some of the deployment constraints, like the latency requirement or the throughput requirements, can actually limit the choice of the models. So there is a video in which I have discussed about the prediction patterns. Go and watch that video, which explains in details about how the models are deployed and what are the different constraints that need to be taken care of. And these constraints has to be defined appropriately at the time of problem formulation. The other important consideration at the time of problem formulation is to understand the interpretability or explainability of the models. All models are not built for purely predictions. Some models are used only for inferences. For example, if you take the case of attrition model, one way to use the model is to predict what is the likelihood of an employee leaving. If the model predicts a high probability, then HR can make an intervention and try to retain him or her. But sometimes organizations build attrition models to understand what factors are influencing employees' decision to leave, or to derive a rule from the data which explains the attrition behavior of employees in an organization, so that the organizations can make a policy intervention or create a strategy to reduce attrition at the organization level. So, in those cases, it becomes very important that we choose a model which explains the attrition behavior. So, we might choose a linear model or decision tree model in comparison to a black box model. At the time of problem formulation, we need to ask business what is the objective of building this model. And we need to capture that information so that it drives our model development and selection process. Bias and fairness is also an important aspect that need to be understood at the time of problem formulation. There are instances where organizations actually have built models and deployed which showed significant bias against a particular gender or race or color. As you can see, there are some news articles which says it appears Amazon actually had developed an AI recruiting tool, and they had to scrap and sell the tool because it showed bias against women. This kind of bias or being unfair to a certain section of society is not acceptable and can also damage the brand value of an organization. So, we need to understand bias and fairness requirements or any other compliance requirements at the time of problem formulation. So, we'll be very cautious and careful about building models and choosing the right model. In this video, we discussed just identifying the problem type at the problem definition stage is not sufficient. We also need to understand what metrics to choose to measure the performance of the models. What are the costs associated with model failures? What are the interpretability and explainability requirements? How to measure the bias and fairness of the models. Thank you for watching this video. I'll see you in the next video with a new topic. Thank you.